All right, so this video is about subtracting segments and angles. So my last video had to do with adding. Now we're going to be subtracting. Things still apply as far as the whole is equal to the sum of its parts. So that's our partition postulate and angle addition postulate. Now what our property says that if A plus B is equal to C plus D, then B equals C and A equals D. Okay, so let's see how this works here. I'm telling you that AC is congruent to BD. And I want to show that AB is congruent to CD. Now what you should notice between these segments that I know are congruent is that I have this shared part BC. If I take away BC from each of these whole segments that I know are congruent, that'll leave me with the part that I've highlighted in green. Then the segments must be congruent. Okay, so my first step here, obviously, is writing my givens. And like I said, I know that BC is going to be the shared part between these whole segments that I know are congruent. So BC is congruent to BC, and that's just by the reflexive property. Okay, so next I'm going to talk about what AC and BD are made up of, and that's the whole is equal to the sum of its parts. I know AC is made up of AB and BC. And I know that BD, which is the other segment, is equal to BC plus CD. So again, that's just the whole is equal to the sum of its parts. Okay, so let's look here. Here's AC, here's AC. Here's BD, here's BD. I can take AB plus BC and plug it in to AC. By the same logic, I can take BC plus CD and plug it into BD, because I know those are congruent. So I'm going to rewrite this. Okay, so like I said, instead of AC, I'm going to write AB plus BC is equal to, now BD, instead, I'm going to write it as BC plus CD. That's just a substitution. All right, now what do I know about BC and BC? Well, just like I stated above, actually I'm going to use a different color here. Just like I stated above, BC is congruent to itself. So I can subtract BC from both sides, and that leaves me with AB is congruent to CD. Oops, this should be 5, shouldn't it? There we go. Okay, and that's just by the subtraction property. Okay, so next, now we're going to do it with angles. I'm giving you the ABD, which, how about I highlight this? ABD is congruent to DBC. So these pink angles are congruent. And I'm telling you that 3 is congruent to 4. I want to show that 1's congruent to 2. So that's where I'm going with this. Okay, so if this whole angle and this whole angle are equal, and I take away these equal measures, then that'll leave me with 1 and 2. So those have to then be congruent. Okay, so starting with our givens. Okay, let's talk about what these angles are made up of. I know they're made up of 3 and 1 and 4 and 2 respectively. So at my next step here, let's say angle ABD is made up of the sum of angle 1 and angle 3. And angle DBC is made up of 2 and 4. And that's just the whole is equal to the sum of its parts. Okay, now I know ABD is ABD right there. And then I've got DBC, DBC, so I can take 1 plus 3 and plug it in for ABD. And I can take 2 plus 4 and plug it in for DBC. So at my next step, angle 1 plus angle 3 must be equal to angle 2 plus angle 4. That's by substitution. Okay, and then what did I say I knew about 3 and 4? Well, if I look up above, didn't I say 3 and 4 were congruent? So if I subtract 3 and subtract 4, that'll leave me with 1 and 2. So angle 1 is congruent to angle 2, and that's just by your subtraction property. All right, so they give me that M is the midpoint of BC and of AD. So let's start with the little part in here. If M is the midpoint of BC, then that must mean that BM is congruent to MC. So I'll have to talk about that. If it's the midpoint of AD, which remember AD is this whole segment, then it must be true that AM is congruent to MD. And that's because a midpoint divides a segment into 2 congruent segments. So if I know these segments that I marked in purple are congruent, and I know these segments that I marked with black are congruent, if I take away BM and MC, that'll leave me with AB and CD. Then I'll have those congruent. But in my givens, remember they didn't tell me right away that these are congruent. I have to infer that from the definition of a midpoint. Okay, so that's what I'm going to have to talk about. So M is the midpoint of BC and AD. Okay, now, like I said, I got to talk about the stuff they gave me. They gave me midpoint, talk about midpoint. I know from that statement that BM is congruent to MC, and I also know that AM is congruent to MD. And that's because a midpoint divides a segment into 2 congruent segments. Okay, next, I should talk about this whole part. Let's talk about what AM and MD are made up of, because this is the whole, I'm taking away the part. So AM is equal to AB plus BM. MD is made up of MC and CD. So that's the whole is equal to the sum of its parts. All right, so here's AM, here's AM. Here's MD, here's MD. So I'm going to take AB plus BM and plug it in for AM. I'm going to take MC plus CD and plug it in for MD. So at my next step, I know that AB plus BM must equal MC plus CD. And that's just based on substitution. Okay, now let me grab another color. What did I previously say about BM and MC? Well, at line 2, I said that they were congruent. So if I take away congruent parts from both sides, that leaves me with AB being congruent to CD. Oops. Should be an uppercase letter. Make sure we're always using uppercase. There we go. Okay, so AB is congruent to CD, and that's because of subtraction. All right, so lastly here, I want to prove that 2 is congruent to 4. Whoopsies. They tell me that angle 1 is congruent to angle 3, and I also know that ABC, so that's this whole angle, is congruent to ADC, so this whole angle. Okay? If the whole angles are congruent and these parts are congruent, I can take away the parts and that'll leave me with 2 and 4. Okay, so let's first talk about what ABC, the whole angles, are made up of. So angle ABC is made up of 1 and 2. ADC is made up of 3 and 4. And that's just the whole is equal to the sum of its parts. Let's see here. All right, here's ABC, here's ABC. So I'm going to take 1 plus 2 and plug it in for ABC. ADC, ADC. So I'm going to take 3 plus 4 and plug it in for ADC. So at my next line, and that's just substitution. Okay, now remember I'm trying to get 2 and 4 congruent. Well, what do I know about 1 and 3? Well, as I said before, 1 and 3 are congruent, so if I subtract them from both sides, that'll leave me with 2 and 4. Oops. And nope, that's good. And then that's the subtraction property. And there you have it.